right, let's go ahead and continue here with our technical topics for the day. And what we're going to talk about before we get into the actual layer 2 or layer 3 troubleshooting is a little bit about the theory of troubleshooting and what types of different methodologies that we can apply in order to establish a general structured approach that we could apply onto any type of problem that we run into in the network. Now you can see there a definition of troubleshooting basically says it's a logical systematic search for the source of a problem so it can be solved. Okay, the key here with this definition, the reason why I have it up there, is that the troubleshooting is supposed to be logical and systematic. Okay, a lot of the engineers that I have worked with in the past, what you will see is that the difference between what you would consider an expert level engineer and an average engineer is that generally an average engineer does not know how to apply a logic and a structure onto this type of approach. So randomly trying different things in the network in order to try to fix the problem does not constitute troubleshooting. Troubleshooting by definition has to be some sort of logical approach. So this is really what our goal here that we're trying to look at throughout the week is how do we apply this type of logic and this type of structure onto the different types of problems that we are going to run into. Now, the reason why we need to use troubleshooting in the first place is going to be pretty straightforward. The main motivation is in high availability environments. Today that we're integrating the voice networks with data and any type of high pressure environment like financial networks, downtime is simply not acceptable. So when you are involved with this type of environment, troubleshooting by far is going to be one of the best features that you can offer towards your employers, and basically it's going to be a justification that your job needs to exist in the first place. So when a problem happens in the network, which inevitably it will, how you actually deal with that problem is really going to show a lot about your understanding of the technologies and your character as an engineer, how you can fix the problem not only in a timely manner, but in a logical manner that you know if this type of problem happens in the future, what is the appropriate fix in order to solve this. And you can see what I have listed there. The one key difference between the expert level engineer and the average engineer. Average engineer is just kind of running around like a chicken with their head cut off. So there's really no structure to how they're approaching troubleshooting. They're just typing random commands, plugging cables in, unplugging cables, trying all sorts of different stuff, and eventually they may get to the solution and figure out what the problem was and solve it. But the issue is that a lot of times it's not in the most efficient fashion, it's not in the most timely fashion. So what we are trying to do here as expert level engineers is try to develop this type of structure that we can follow. And even if we are involved with a high pressure environment, because if you've ever worked for a financial network before that is doing stock data or something like that, if there is network downtime, then everyone is running around in circles with the network on fire trying to fix it as soon as possible. It definitely can be very stressful to get involved with a troubleshooting environment. But if you have this structured approach that you can apply onto different cases, you'll be able to take a step back, calm down, keep a cool head, and say, I know that I can follow XYZ in order to accomplish what I'm trying. That doesn't work. I know I can fall back to X and follow the approach again. Now, especially related to the CCI lab exam, there is that innate factor of pressure and stress because we're trying to solve the network requirements within an allotted time frame. So with 2 hours for troubleshooting, may seem like a lot of time up front, but when you actually get in there, if you have 8 to 10 tickets, you may not be able to spend more than 5 minutes apiece on the individual tickets in order to try to solve everything as a whole. Okay, so as I mentioned here, what we are going to be focusing on a lot this week is actually developing this type of structured troubleshooting approach. So the different steps that we're actually going to go through will be a little bit different depending on what the problem is. You see the example here. It says troubleshooting a voice over IP call quality issue is going to be different, obviously, than an OSPF neighbor adjacency issue. But really, they're going to involve the same sort of logical approach for the actual troubleshooting. Now, one thing that is kind of interesting about how you can develop this type of structured approach is that it is very similar to how the scientific method can be applied in traditional physical sciences or chemistry, biology, that type of stuff, for conducting experiments where we basically have some sort of logical workflow that we're going to run through to figure out what is the end result of this question that I'm trying to answer. So we can see here's a workflow of what the scientific method is. It says first off we want to define a question. So there's some sort of problem that we are trying to solve. Then we want to try to gather the facts together. We're going to observe. We're going to form a hypothesis, so we're making a guess on something that we're trying to either prove or disprove. We're going to actually do the experiment to try to gather more data, collect the data, analyze it. Based on these results, we figure out, are we satisfied with this? Do we want to report our findings, or are we going to start back from the beginning and run through the experiment process again? So even though this is not directly applicable to network troubleshooting, it's the same type of logic that we would want to go through. Now, as we could adapt this to a troubleshooting method, we see the same type of logical steps. Okay, in the case of troubleshooting, first thing we need to know is what is the problem that is occurring in the network. So whether this is from a user report, like a problem comes into a support ticketing queue, or whether it's some sort of proactive management, like a NetFlow alarm or an RMON or an SNMP alarm, we need to know what is the problem in the first place. Now, once we have a general idea of what the problem is, then we want to look in to the problem further, try to get as much information as possible to try to isolate the issue as much as we can. Because we don't want to waste time troubleshooting an email issue and looking at server information when there's something wrong with the layer 2 network that's stopping communication from the end client to the server itself. So this gathering the information stage, this is where we're kind of forming that hypothesis, figuring out what could be the possible problem in detail, and then next step, how are we actually going to fix it? So is it a physical cabling problem? Is it a configuration problem? Is it some sort of application level issue? We want to know step by step what is the process we're going to use in order to apply the fix, because if there is a problem, we also need to know what are the reverse steps in order to roll back the fix. Okay, we'll see as we get into more complicated troubleshooting, this is really where your change control process is going to be key. If I have some reachability issue in the network and I go out and change 100 different variables in configuration and the problem is solved, I don't necessarily know what was the root cause in the first place, because there's 100 different changes that I make, 100 different possible fixes out there. So when you're defining the fix here, you want it to be as specific as possible and ideally as focused and minimal of a change as possible, so you can actually observe what the results are and figure out, was this actually the root cause, what my initial assumption was, or is it some other unrelated problem in the network? So once we actually make the change, then we want to look at what is the result of this and figure out, did this fix the problem? Does it meet our criteria or not? If it did fix the problem, ideally in a live production environment, you would want to document what the fix was. So if this problem happens again in the future, you don't need to start from scratch. You have some sort of internal troubleshooting knowledge base that you could reference that is specific towards your type of network topology or your individual application requirements. Now, if the problem does not get fixed, then we need to know where to fall back to. And this is where the logic breaks down for a lot of average engineers that really do not know how to apply a structured troubleshooting approach. So if the initial assumption was wrong and we need to start with something else, taking just a random stab in the dark is not necessarily the best approach. We want to fall back to this logic, try to gather more information, think about what variables did our change have an effect on, which of them did it not have an effect on, and why or why not is that case. Based on that, you should be able to proceed further or figure out whether you need to roll back your changes before you make any other large modifications of the network. Okay, so let's look at these individual stages in a little bit more detail here based on what I have on the workflow. Now, first and foremost, we need to figure out what is the problem in the first place. So as I mentioned, this could be some sort of reactive system, like we're waiting for the problem to be reported into us or waiting for us to notice the problem. Or it could be some sort of proactive management, like SNMP says that our T1 link to the service provider goes down. So based on this event-driven process, then we need to know why did this happen in the first place. So what is the root cause of the problem? So in either case, whether it's some sort of ticket, like we would see in the troubleshooting section of the exam, or whether it's some sort of proactive management, either way, the next step is going to be to find more information about the problem. Now, this is where we're going to spend a lot of time this week talking about what are the different methods we can actually use to gather this information. So what are the different appropriate show commands? What are the debug commands? What are the different miscellaneous tools like ping, traceroute, telnet, etc.? The goal is that we're trying to isolate the issue as much as possible. Now, from a real-world point of view, a lot of the times debugging is not allowed in a production environment. Now, depending on how strict your change control policy is, a lot of times if an engineer says debug anything, it's immediately grounds for termination. The vast majority of debugging in production does not happen unless you already have a network down emergency. So basically it means you cannot make the problem any worse than it already is. The network is 100% broken and you need to get in there as quickly as possible and diagnose what the issue is. But ideally, we don't want to rely on debugging as our primary tool in our toolkit here. So the show commands for the individual technologies, definitely we want to look at the explanations of the outputs, and then different types of other methods we can do like ping, traceroute, IP SLA, that type of stuff. But once we proceed out of this phase, ideally we have as much information as possible as to what individual devices the problem can be broken down into, and then what individual technologies they are related to. So this is where we would want to figure out if the user is having an email problem. Is it because the link is down because someone was doing construction in the area and did a fiber cut? Or is it because there's some sort of problem with the settings on their actual application? But from a very vague trouble ticket, a lot of times as they are, user reports an issue saying, I can't browse the web, okay, or I can't ping. A lot of times that doesn't really give us much information. So at this stage, we need to analyze what is the current baseline of the network, what is the current operating capacity, and then figure out based on this, where can we narrow the problem down further into. Now, this actual process of gathering the information, there's a couple different schools of thought on methods you can apply onto this. In the end, it's really going to be a personal preference of what works efficiently for you. We'll talk about what are some of the different methods and how you can apply them. Then we will take a look at examples on the command line of how you actually apply this in real live troubleshooting. But in either case, the main key with any of these methods is that we are breaking the network as a system as a whole. We're breaking the system down into functional layers that describe what are the different components of the network and what are the individual jobs that they are supposed to perform. So this is where we would look at the network as a collection of OSI monolayers or TCP/IP monolayers, where we understand from a fundamental point of view there is a different function that a layer 1 packet over SONET link performs versus our layer 4 BGP or layer 3, layer 4 BGP routing session. Because we don't want to be troubleshooting something at one layer that is really unrelated to that type of problem. Okay, so like I mentioned before, we're troubleshooting email when the link to the service provider is down. Now, to actually figure this out, where to start, a couple different common methods. Okay, the three I have listed here: a top-down approach, a bottom-up approach, or divide and conquer. Okay, now, top-down and bottom-up, as you would guess, those are going to be based on the layers. Do you start at the application and work down, or do you start at the physical layer and work up? Okay, now, there's different reasons why one would be more appropriate than the other. It really depends on where you think that the problem could be, based on the information that you gathered in the previous step. So if you have a gut feeling that this is a layer 1 issue, then it's probably not the best approach to start at the top of the OSI model and work your way down. But do remember that when we're talking about the layer or the network in functional layers here, any problem at a lower level layer will inherently affect all layers above that. So if a physical link is down, then obviously you're not going to be able to browse the web. So if there's a frame relay problem, that's going to affect OSPF. If there's an OSPF problem, that's going to affect SNMP. So you need to think about, based on the information I have up to this point, where does it most likely look like the problem could be in the network? Is it related to layer 1, layer 2, layer 3, etc.? Now, as I mentioned, within the scope of the CCI lab exam, there is not going to be layer 1 troubleshooting, so we are mainly going to be focusing on layer 2 and above. Okay, our first approach, as I mentioned, the top-down, would be to start at the application level, the application layer, and work down from there. So most of the time, this is useful for tickets that come in related to the actual application themselves. So if the user says, I cannot get to my mail server, I can't send mail, then maybe it's a good idea to actually go to their end host, try sending mail, and look at what the result is. They have the wrong server parameters configured, the wrong port numbers, that type of stuff. Now, from our perspective, as constrained to the CCI lab exam, this would probably not be the best approach because we're really not dealing with the applications. We can pretty much safely assume that any problem they are introducing is related to the network layers. So it's going to be constrained somewhere between maybe layer 2 and layer 4. Now, on the other hand, the bottom up would be starting at the very low level physical layer, doing tests, and then working our way up from there. Now, just like top down, there are some cases where this is advantageous. So for example, let's say an SNMP trap comes in that says there is a link down event for the link to the service provider, or the BGP peering relationship went down between my edge router and the service provider. So in that type of case where we suspect that maybe it's a layer 1 issue, maybe it's a layer 2 issue, then it would make sense to do basic checks like, is the link in the up status? Do I have basic layer 2 reachability on that link? So if it's frame relay, do I have LMI keep alive? If it is Ethernet, do I have basic Ethernet keep alive? Is the link up? And once we get past that point, then we move on to layer 3. Do I have my basic IP addressing configured correctly? Is there an IGP adjacency, etc.? Now, just like the top-down approach, you can run into that problem where the bottom-up is very time-consuming if the problem ends up being in a higher layer. So if the ticket comes in, the user says, I can't get to the email server, and it ends up being that their IMAP settings are wrong on their end host, then we wasted a bunch of time checking our serial links, checking our layer 2 encapsulation, layer 3 routing, etc. So a lot of the times what a lot of people will use is kind of a hybrid between these two, the top down and the bottom up, which is the divide and conquer approach. Now, divide and conquer basically says that we're going to make some sort of educated guess on where we think the problem is in the first place. So we're trying to troubleshoot this email problem, and I don't necessarily think it's an application issue. I don't think it's related to the actual server itself. So I'm going to check, first off, can I actually ping the mail server? So if I send a basic ICMP ping out and I do not get a response back in, where am I going to go from there? When I look at mail and where it's related to ICMP ping is a basic layer 3 function of the network. So if layer 3 is down, then it means I want to go further down the stack. I would want to check the physical cabling. I would want to check the basic layer 2 information. Is the VLAN assigned properly? Is spanning tree working across the network? Now, likewise, from the opposite point of view, if the ping is successful, then we would want to go the opposite direction. So ping is working. This means that layer 1 is fine. Layer 2 is fine. Layer 3 routing is most likely fine as well. So then we would go further up the stack, looking at the application level issues, because the ultimate goal here is to try to cut down on the amount of search time that we're using to figure out where is the problem in the first place. Because again, at this phase, we're still trying to figure out where is the problem isolated to. Is it one physical device? Is it one physical link? Is it a protocol stack itself? We're trying to constrain the problem as much as possible so that when we actually do make our changes, we want to make sure that we're not changing too many variables at the same time. Okay, so at this point, we now know what is the problem, and we have a pretty good idea of where we would want to start to try to fix it. So again, this is the key point in the troubleshooting process where change control is definitely going to be your friend. So if I think that the problem related to the mail server is application related, I don't necessarily want to reboot the server and change the user's mail settings and to reboot their switches or their wireless access point all at the same time, because then if the problem is fixed, I don't really know what was the root cause in the first place. Now, even worse than that, if you make a bunch of changes quickly, you can compound the problem and make it even more convoluted to try to fix it than it was in the first place. So before you actually implement any type of fix, you need to step back and spend a couple minutes saying, this is what I really think that the problem is. These are the steps that I'm going to go through to fix it. So I'm going to change this configuration, I'm going to shut this link down, bring it back up, etc. So we want to know when the change is actually implemented. If that does not fix the problem, what do we need to remove or what do we need to roll back in order to get back to the same baseline that we had in the first place? And you'll see in a lot of networks today, especially with high availability requirements, pretty much all of this stuff is going to be logged anyways. Something like, let's say, AAA accounting. So if there's downtime in the network and there's logs of your username going into the different equipment, making all sorts of changes, well, management probably is not going to be very happy about that. So it really depends on your individual environment, how strict the change control is going to be. I've seen some very high availability networks where the change control window is like an hour and a half on a Saturday afternoon, and basically the engineering team spends all week planning what are they going to make the change on the next Saturday, implement the change. If it doesn't exactly work how they thought it was going to be, they roll it back and then they have to wait to the next week. Because remember, the ultimate goal of the network is not really your playground for changing all sorts of configurations around and seeing what happens. It's the business case that is riding on top of the network. Okay, next, once we actually implement the change, we need to figure out what was the actual result of that. So depending on what the problem was in the first place, this type of phase could be pretty straightforward, or it could be a little bit more complicated. Now, the original example I was talking about, user submits a ticket saying they can't send email. You make a change, they now can send their email. That's a pretty straightforward fix. So the application was broken before, now it works. You know that your solution was fine. Now, for other types of issues, for example, voice over IP call quality, that type of stuff, it gets a little bit more complicated. Because if a user says, I can't make a phone call, or I'm on the phone call and it's very choppy, the call is dropping out, make some sort of changes in the network, you really don't know if your change was what fixed the problem, or it was some sort of kind of freak traffic flow where you need to wait for longer term traffic patterns in order to figure out, does the problem happen again? So not all of these issues would be cut and dry in a live production environment. From our perspective with the CCI lab exam, I would assume that they will be cut and dry. So if you fix the problem based on what the ticket says, you should be able to do a discrete verification that you know 100% sure whether the problem was fixed. And this is the same type of verification that they will do in order to perform their grading process. So let's say, for example, the ticket says users are complaining that they can't reach this subnet. And the goal is that we want to get reachability to that particular network. So at the end of your changes, you do a ping or you do a traceroute or a telnet and you are able to reach the destination, then I would safely assume that that particular ticket has been solved. Okay, now we get to the point where the logic breaks down for a lot of engineers. This is where we start to go into panic mode. So if the problem was not solved, what do we do? This is where a lot of people will start just trying random fixes, shutting down links, rebooting devices, making all sorts of changes to try to quickly fix the issue. But a lot of times the problem ends up being compounded when this logical approach is not strictly followed. So like I mentioned within the CCI lab exam, there is going to be that innate stress factor, that timer that you'll see counting down on your desktop. If you try to make a fix and it does not work, you need to take a step back and use this logical approach to figure out where do you need to go from here. So at this point, you need to figure out the original assumption that I made of what was the problem. Was that actually the issue or was it not? Was there some other variables in the network that I really didn't take into account? Or is it just that the actual configuration or the actual fix that I tried to apply was not appropriate? So maybe you found the problem, the root cause of the problem in the first place, but it's just that your actual change was not what was appropriate for it. Yeah, but the key here is that before you make any further changes, you need to figure out what are the results of what you actually did change up to this point. So did your configuration change, or whatever your change, did it have any effect whatsoever? If it did have an effect, did it make the problem better or did it make the problem worse? So let's say we're troubleshooting a reachability problem. We make some sort of routing change. The users who were complaining in the first place are still complaining, but now we have more users that say, well, I can't browse the web either now, or I can't send email either. So if it made the change worse, we need to reevaluate what the fix is or what the originating problem was. Now, if there was no result whatsoever, then it would be suspect whether our fix was appropriate, or whether it was maybe applied to the right portion of the network, or whether the problem that we assumed was the problem actually is the root cause of the issue in the first place. But the key, if we look back to the workflow here, once you get to that last decision process where you're figuring out, did this actually fix the problem or not? If the problem is not fixed, this is where you need to stay calm, stay cool, and figure out what is the next logical step in order to approach this. Do I need to roll back my previous changes, or can I proceed further and make further changes to see if the issue is going to be improved? So we'll see this general case, this structured troubleshooting approach, we are going to be able to apply it whether we're talking about layer 2 troubleshooting or layer 3 troubleshooting or application troubleshooting, because it's a generic logic that should be used regardless of what type of issues that we are running into in the network topology. Okay, any questions up to this point?